Okay, hello everyone. In this video we are going to start to implement a bit more meaningful quest than the last one. I'll show you the design of the quest we are going to implement. So we want that first the player should find a portal, and after finding the portal you must stand on top of the portal for 5 seconds to summon 4 cubes to the level, and when the cubes are spawned to the level, the player needs to push them back to the portal to deliver them to some another realm or something like that. And if he is able to complete that objective under 60 seconds, we will reward him with a special reward, which will be a shortcut to the end of the level. Otherwise, the player must reach the end room through some maze. So he needs to find a way through a longer way instead of just using a door as a shortcut. And when he reaches the end, we'll play some simple cutscene and end the quest. Before we jump into the quest implementation, we need to set up a couple of actors. So if we look at this diagram here, we see that at least we need a portal. So let's create a portal actor. And then we need this cube actor, some physics simulated actor the player can push, and also an actor that can spawn those cubes when told so. And then we need some simple door so we can open it or close it. So let's jump to the Unreal Engine and head to quest tutorial, and let's actually create a subfolder here. Let's call this actors. We're going to start with the door. So let's create a new blueprint class. Let's pick actor and let's name this BP underscore door. Okay. So what we want to do is basically that we have just a boolean state for this door, if it's open or not. So let's create a variable and let's call this b open or b is open. So if this variable is true, we want that the door is open, otherwise it stays closed. And we can just simply add a static mesh here. Let's add a cube and let's scale it a little bit like so. And let's put it on top of the scene component. So basically what we are now doing is that if the door is closed, this cube stays in this position. If it opens, then we will interpolate this cube downward so it goes under the floor. So let's jump to event graph. And we're going to do that in tick event. And I'll rename this door mesh. So depending on this boolean, we want to interpolate this. So let's make this real simple. We just take door mesh and we want to set its relative location. So relative location to this root component. Set relative location. So this new location should reflect the location we want to interpolate this. We can get current location of this. And now interpolate from our current location towards our target location. And our target location will be determined by if this is open or not. So let's interpolate towards our target. There's a function called reinterp2. So our current location is our current relative location. And to the target we want to pick either open or close location. So let's select a vector based on this boolean. So if the door should be closed, so B is open is false, we want this door mesh to be in this location, so let's just copy this location from here. Oh, we can't paste it here, so let's just type it. So our Z position should be 50. And when the door is open, we want this position to be -50. I'll actually drag and drop this to the level so we'll see the size of the door. And as we can see, the door is quite small, so let's actually make it a bit bigger. Let's say it's 3 meters wide and 3 meters tall. Okay. So let's adjust it again. So instead of 50, it should be 140, and then -140 when it's open. Then let's wire delta time to the interpolation function, and we can just type our interpolation speed here. Let's try, let's say 5. Okay, so let's test if this door works. Let's make this public so we can edit it in the level. So if I tick this open and we go to the level and play, we should see that the door opens. Maybe it was a bit too fast. Let's make this a little bit lower. Let's try 2. Okay, we see that the door is opening now. Okay, that was the door. Then another thing we need is the cube. We can push around. We already have one in the third-person template level, so we are gonna use some custom version of this. So let's just get rid of these. Okay, so let's create a cube. It will be an actor, BP underscore quest cube, for example. For this, we just want it to be just a simple static mesh as a root component. Let's maybe use the same cube as the one that comes with the third-person template. Cube, I think it's this one. And let's find the blue material, or well, blue. I think it's this solid blue. Okay, so the cube is there. And what we want to do, let's enable simulate physics so we can push it around. And now let's test this. Okay, I can push it around. We have the cube. Then, as we don't want to place these to the level, as the quest requires that at certain point of the quest we spawn these cubes, we need to create a spawner that basically just spawns an actor of a class that will be this cube when it's told to do that. So let's create another actor. Let's call it bp underscore quest cube spawner. And for the preview purposes, we can just copy paste this to this actor, so we know where the cube will be spawned, and we have a nice preview. But for this, let's make this hidden in game. So in the game we won't see this. This is just for editing. All right. And one more thing we want to do with this preview is that we disable the collision, so it won't interfere with the gameplay. Then to event graph, we just create a new event here. Let's call this spawn cube. So when this gets called, the cube is spawned, and we can spawn the cube using function spawn actor from class. And let's pick our quest cube, and we will use the spawn transform of this actor. So let's get the transform of this actor. Okay, so the cube is now spawned if we call this function. Let's test this actually. If we add this this function called the backing play, we can test it easily. Spawn cube. So let's spawn cube on backing play for testing. So let's delete this and let's place quest cube spawner instead of the cube, and we should have a cube spawning in the level. Okay. We forgot to toggle the physics simulations off from this cube, so let's do that. So let's tick the physics simulates off from the cube spawner. Okay, we can now delete this as we know that this function call works. Okay, then what we still need, we need the portal. For the portal, let's create some material, so we can indicate where the portal will be. Let's place it somewhere around here. Let's actually remove these. So the portal would be somewhere in this area. So let's create a decal material to indicate the location. We'll just create a quick and dirty indication material, m underscore portal decal, for example. And let's pick deferred decal, and let's change the preview to the plane, and let's pick translucent. Actually, let's change the surface still so we can get a better understanding how this looks like. We want it to be a circle or something similar. Let's create radial gradient exponential, so this will create us a circle. And now if we just take a sine from this, we will get a nice circle. Okay, and what we want with this, let's make this as an opposite, and for emissive color, let's just create a constant. For example, let's make it blue, and multiply that some amount to get a little bit of glow. Okay, here we go. And then let's change this to deferred decal. Okay, so now if I add a decal, let's see how does it look. Decal actor and decal material, and there we go. We have a portal. Okay, and then we need to implement logic for this portal. So let's create a blueprint, and again actor pp underscore portal. So what this portal should do, first of all, it should detect if the player is standing on top of the portal, but also it should detect if any of these cubes starts to overlap with it, so we know that the player just delivered one of the cubes to the portal. So let's create a trigger box under this portal. We can use, or actually let's use a sphere, because the indicator is circle. So let's add a sphere collision here, and let's call this trigger. And we want that this overlaps with all the dynamic actors. So let's leave this as it is. So now let's get rid of these, and let's bind on component begin overlap. So when this trigger gets an overlap event, we can do our logic. So the first thing, if this other actor is the player, we want to do the first logic, that the player entered the portal. Otherwise, if this actor is a quest cube, we want to run another logic. So let's drag this, and let's cast this to a third person player character, which is our class of our player character. Actually, let's split this to sequence so we can get things more organized. So first, let's check if this other actor is third person character, and then if this is our cube, we do things differently. Okay, and in case that the player character enters here, we will implement the logic a bit later. But in case that you push a cube here, we just say that the cube should be destroyed. So let's call destroy actor for the cube. So when the player pushes the cube here, the cube is just destroyed. Okay, let's try this. So let's put the portal there, the same location as our indicator. We need to scale it a little bit. Okay, I think that's good. Let's save and let's hit play. So if I push this cube to the portal now, it will disappear. Okay, in the next video we are going to implement these gameplay actors to our quest, and we will create the quest to drive this design we had here. And let's see what we come up in the next video.